We're going to get started with the first presentation. The first speaker that we have today is Dr. Francesco Di Gioia. He is an associate professor of vegetable crop science at Pennsylvania State University. He is a vegetable specialist, and the primary goal of his integrated research and extension program is improving the sustainability of vegetable crops and their nutritional quality. Working across different crops and production systems, his research is focused on developing and optimizing precision agriculture solution aimed at improving crop resource use efficiency. This includes irrigation, fertilization, and energy, reducing the use of synthetic inputs, and improving the nutritional value of vegetable crops. In his presentation today, Dr. Di Gioia is going to be talking about anaerobic soil disinfestation. So ASD has been recently proposed as a biological solution for the management of weeds and as a tool to facilitate the transition from conventional to organic production. He is going to go over how ASD is applied and can be integrated with other biological solutions, the principles and main mechanisms of weed suppression currently known, and the factors influencing its efficacy in weed suppression through some research-based examples. Francesco, if you want to go ahead with your presentation.
Thank you, Aparna. Good afternoon, everyone, and thanks for the invitation to present in this workshop. As you mentioned, I'm going to focus on ASD as a biological management tool to control weeds, and a lot of the present, like the material that I'm sharing, the information that I'm sharing in this presentation is the fruit of the work that we have been doing over the past 10 years, in particular in collaboration with Dr. Erin Roscoff and Jason Ong, and also Xin Zhao in Florida, and then across along the East Coast through the project that I'm showing here in this slide, which I have the honor to lead, and includes is a multidisciplinary project, and we have been looking at enhancing and optimizing ASD for organic specialty crop production systems. With that, really the objective here of this presentation is to provide an overview of how ASD affects weeds, can be used to control weeds, especially in specialty crops. And I will go very briefly through an introduction and then show how ASD is applied and the main principle and factors that affect weed suppression through ASD. Since I was the first presenting, I thought it would be good to mention the fact that weed management in organic specialty crop system is rather complex and typically requires a holistic approach, and it requires the integration of different solutions. There is not a single solution that could work. And the idea that I'm proposing here is that ASD could be one of those tools, in particular, a tool that allows us to reduce the amount of seeds present stored in the seed bank in the soil. And so that's the main idea that I would like to propose. Another aspect that is important when we talk about organic production system is that we need to select our tools, our management tools, taking in consideration the fact that we want to optimize and maintain and possibly enhance the health of the soil. This is critical for any soil-based approach, but particularly for organic production systems. And ASD is an approach that can enhance soil health. So it's one of the tactics that we can use in an organic production system. Now, if we look at the different strategies, we can distinguish prevention, cultural practices that are used to suppress weeds, physical and mechanical methods. And among those, we could say, cultivation practices, soil solarization, and soil steaming are pretty common. On a small scale farm, also soil tarping is common. And then what we have is a series of biological solutions, and among those, biosolarization and anaerobic soil disinfestation are kind of the latest solution evolved, and both are biological methods. And we are going to focus today primarily on anaerobic soil disinfestation, but like I said, biosolarization is relatively similar as an approach. Now, one thing I would like to mention is that anaerobic soil disinfestation was developed initially as a soil-borne pest and pathogen management approach, and it was developed only when the metal bromide, like the chemical fumigant, was being phased out, and so we can see starting from 2000 is when ASD and biosolarization were developed. The same concept, the principle, were known even before, but only after the phase out of the metal bromide, we started paying attention to these approaches. And so our ASD has been developed, essentially combining the application of organic amendment, which is a traditional approach to improve soil health and manage soil-borne pest and pathogen, combining it with the principle of soil solarization and soil flooding. And what people saw is that when they were applying soil solarization in combination with organic amendment or soil flooding with organic amendment, the efficacy of the treatment was increased. And so while in the case of biosolarization, we have, the combination of all the three components, but the high temperature is still an important factor. In the case of ASD, we combine essentially soil saturation, which is different from soil flooding, soil tarping, which is different from soil solarization in the sense that we could use clear or opaque type of film, and then organic amendment. We are trying to use organic amendment that are readily labile, not any type of organic amendment, and that's what led to the development of anaerobic soil disinfestation. Now, in all this, one thing that is important is that as we go from the primitive methods to those more advanced methods, the application timing is reduced. These are both pre-planting. All of these are pre-planting methods, approaches. And so the timing of application is important. And the other thing that is important is that the efficacy of control of soil-borne pests and pathogens is improved. Now, a big difference between biosolarization and anaerobic soil disinfestation is the reliance on temperature. And anaerobic soil disinfestation is temperature dependent, but not as much temperature dependent. And so we can work with this approach also in temperate region. Like, I'm working in the Northeast of the US in the Mid-Atlantic region, and we have demonstrated that ASD is a solution that can work in this environment. Now, I mentioned that ASD was developed primarily for solid-borne pathogens, but while doing research on this system, people realized that ASD is also effective in controlling weeds and also nematodes. And here is in this table, I kind of collected like some of the weeds on which ASD was reported to be effective, and that include broadleaves, grasses, and nutsedge. Now, the efficacy is higher, I will say, against broadleaf. It's a bit lower in grasses and is even lower for nutsedge. But there's a lot of studies that show that ASD could provide a good efficacy as a biological control solution also against nutsedge. So here is how we apply ASD. So the first step, we distinguish typically three steps. The first step is to amend the soil with a readily decomposable organic material. Ideally, the carbon-nitrogen ratio is 20:1. And the idea is that the carbon, the sugar that we provide, with which we amend the soil, is going to feed the microbes. They will start immediately feeding on that sugar, that labile carbon. Then what we do is we mulch the soil possibly with an oxygen impermeable film, and this helps to maintain the anaerobic conditions, also increase the temperature, and it helps with the decomposition of the organic amendment. And then what we do is via drip irrigation, Also, we saturate the soil with water, and that facilitates not only the development of anaerobic condition, but also the diffusion of the products that are generated during the ASD treatment. So now in this picture, I'm showing like the application on raised bed, and this happened to be in an eye tunnel, organic eye tunnel with Amish growers. So they're using horses to do all the work. But this could be done also as a broadcast application and using regular equipment. And in this case, we will cover like the entire surface is pretty much the same approach. One advantage of anaerobic soil disinfestation is the use of different alternative organic amendments. We have been working a lot with middlings, and this is available throughout US, but there's a lot of different carbon sources like molasses in Florida combined with poultry chicken litter, or rice bran has been used a lot in California and in other states as well. And we have been working on the use of also alternative carbon sources. So this is just to mention that is a method that is very flexible in the way we can apply it. And it could also be integrated with other biological solution, including the use of cover crops. So here I'm reporting the QR code of a manuscript that we published a few years ago. And here I'm just mentioning that last year we did a webinar just focusing on how to integrate anaerobic soil disinfestation with cover crops, and how you can plan and integrate like within the crop cycles ASD at different time of the year depending on the specific cropping system. So here's the link to that webinar. Now let's go to the principle, to the mechanism. So imagine that this is our soil, and we amend the soil with a labile carbon source. That labile carbon source typically has also organic nitrogen. We try to incorporate that within the root zone, and then, as we mentioned, like we will mulch the soil and saturate it with water via irrigation. When we do this, what is happening is that immediately the soil start going, like the microbes start feeding on that carbon, consume all the oxygen, and the soil goes anaerobic. And we have, a shift of the microbial community. Now, what happens is the organic carbon, the soluble sugar, the fraction that is most labile of the organic carbon, is going to be used for fermentation process by all these microbes that are in the soil, and we have the production of organic acids and volatile organic compounds. And just, as information, because there's nitrogen also involved, there are dynamics that affect nitrogen availability as well. But I'm just, mentioning it without going too much into the details. So when we look at what is the mechanism through which ASD is affecting, suppressing weeds, there's different factors, different mechanisms that we can mention. One of those is the organic acids, volatile organic compounds that are generated, some alcohols like ethanol and other alcohols, volatile organic compounds. Those are toxic or suppressive against weeds. And that's one of the main factors that we know is acting. Then low pH is linked to, like we have generation of low pH because the organic acids lower the pH. It's a temporary shift of the pH, but during this temporary shift, we have generation of reduced form of iron, manganese, and aluminum, which also are toxic for seeds, for wheat seeds. And then low oxygen is another important factor. And essentially what we do when we saturate, when we apply ASD, and we saturate the soil with water, so making it really moist, a lot of the seeds will germinate. And by the time, anaerobic condition develops, the oxygen will not be available for those seeds to continue to go on. And so you have what's called the phenomenon called soaking injury, where the seeds that are germinated then, are terminated because they are killed by the low oxygen, the lack of oxygen. At the same time, we have generation of ammonia, depending on the pH, and a lot of different sulfur compounds. Those are also demonstrated to be toxic for weed seeds. And so that's another factor. And then Another aspect, even if sometimes we don't achieve relatively high temperature is a cofactor. And if we achieve temperature above 50 Celsius degree, which is about like above 130 Fahrenheit, then that also could kill some of the seeds. And then the last aspect is the biological control, meaning that with ASD, we have, after ASD even, we have an activation of the microbial activity, and these microbes can degrade, decompose seeds. Now, most likely, the combination of all these factors, all these mechanisms, is what is contributing to the suppression of the weeds. Here I'm going to the next slide to say that, of course, ASD has some limitations. And the primary limitation is the fact that ASD doesn't have a strong residual effect. There are some effects that, like we can see post-ASD, but in general, ASD is effective in controlling the seeds that germinate and that are not dormant during the ASD treatment. Any seed that didn't germinate during that period and so was not killed through the ASD can germinate after breaking the dormancy. And the other aspect is that if we have seeds that recolonize the soil through wind dispersion or other mechanism post ASD, then there is nothing we can do about that. That's why we say that ASD should be integrated with other approaches. One thing that I would like to mention here is that we could use, like, I'm switching now to talk about the factors that we that affect the efficacy of the ASD treatment. One of those is the type of organic amendment that we use, the quality of the organic amendment, and one thing that has been discussed in the literature is that if you use a liquid carbon source in general is more effective than a solid carbon source. But there's also studies showing that, for instance, wheat middlings is more effective than molasses. So there's, the type of carbon source is a factor, but it's still, there's a lot of work that we need to do to go deeper into this. Now, I would like to report the results of a study that we conducted in collaboration with Erin Roscoff and Jason Ong while I was a postdoc at UF. And this was a pod study in which we tested like different rates of molasses. You can see the rates here reported in equivalent of gallons per hectare, but everything was done in pods. And what we see here on this graph is that increasing the rate, these are relatively high level of molasses, I will say, but the purpose of this study was to investigate like how much we could push and also any phytotoxicity effect. So what we see here is that increasing the rate, we have a proportional increase of cumulative anaerobic condition. The soil goes more anaerobic over the entire period. And then we have also a reduction of the pH, which we mentioned before, but sometimes that is not like at certain level, there is not much of a reduction there. And what we did was through Erin Roscoff lab was to analyze the content of organic acids. And what you see here is the cumulative, the total of the organic acids, and those increased with increasing the rate of molasses that we applied. And these were the data that I collected on the coverage. And you can see here the effects. So this was the control with no molasses. This was the standard rate of molasses that we used. And then, increasing rates of molasses, you see that the amount of weeds were reduced, like you see here, the average across 4 reps. Now, one thing is important to mention is that, ASD can kill also our plants. And so, it's because of the lack of oxygen also that we have, the plants, the weeds will not germinate during, like once the soil start going anaerobic. And so we see the effect of that for some time. Now we have seen these also in the field, and you can see here like 2 different rates of molasses combined with chicken manure. In this case was the spill of the molasses from the bed that really created this effect here on the weeds. But we saw that also within the beds. This is what I was going to mention before about liquid versus solid and the quality of the carbon source, of course, like the lability of the carbon has an impact on how anaerobic the soil goes and how effective it is in suppressing weeds. And the other aspect that is important is the carbon nitrogen ratio. I'm not going to mention about this because I believe Xin will talk more about this, but there's not clear evidence whether increasing the proportion of nitrogen is more effective. But this is something that we need to continue to investigate. Here, I just want to report the case of a grower on which we recently, this past summer, did an application. This was a raspberry cucumber organic grower affected by dagger nematodes that were transmitting a virus that was taken from weeds and then to the crop. And so this was a big problem. This is how we applied the ASD with middlings. You see bags here. We used clear and black tarp, and then we had a section here that was the control where there was no covering, but there was still irrigation. And I'm reporting this to show the difference, the effect of the temperature, the film on the temperature, and to show the effect on the weeds. So here there's like barely no weeds because we work the soil. This is 28 days later. When we go to retrieve the plastic, we can see weeds all over the edges. And when we remove the plastic, both clear and black film, there's no weeds here. And this is like an application that we did over the summer, and with the clear film, we reached temperature that were above 50 Celsius. So temperature could be sometimes a factor, but with the black tarp, we did not see, we didn't achieve 50 Celsius. So that, I would say because we had control on both, that's, the temperature is a cofactor, but it's not the main factor when we talk about ASD. And this is the graph showing how the soil goes anaerobic immediately. In this case, there was some anaerobicity developed even in the control because of the water. And this is the cumulative soil redox potential that we estimated with the black, clear, and clear TIF and with the control. With this, I would like to close and say, I hope this was useful information. I just wanted to mention that we have started a new project that is going to focus on the use of ASD as a management tool for weeds in particular. And the idea is that ASD can help with the transition from conventional to organic production systems. So stay tuned on our work. This involves also colleagues from Florida. And with that, I hope that I didn't go over with time, but
Thank you so much, Francesco. You are perfect on your timing. So if you have any questions, feel free to post them in chat, and Dr. Di Gioia will answer them over the next few minutes. Up next, our second speaker today is Dr. Xin Zhao with the University of Florida. Dr. Zhao is a professor in Horticultural Sciences Department at the University of Florida. Her position provides research and education programs in organic and sustainable vegetable production with the overall goal of improving and integrating environmental stewardship, soil health, plant health, and resilience, crop productivity, food quality, and farm profitability. In her presentation today, she'll be talking about the highlights of some of her research work around the anaerobic soil disinfestation. And this is from a series of field trials looking at adapting and optimizing anaerobic soil disinfestation in organic, vegetable, and strawberry cropping systems. Like I mentioned, she's from University of Florida, and this research was done in Florida's sandy soils with an emphasis on weed management. So like I mentioned, the speakers will have time towards the end of all their presentations. So in the meantime, feel free to post your questions in the chat. Dr. Zhao, if you want to get started, thank you.
Thank you so much, Aparna, for this great opportunity. Can you see my screen okay? Okay, great. So yeah, thanks to Francesco, who did a wonderful overview. on the biological control measure, in this particular case using ASD, of course, for weed management, and other benefits in terms of ASD can bring to organic farming operations as an integrative tool. So really following up here, I like to use a case study approach to really share some learning that we have so far from our ASD research work. As you can see, some of the studies are still ongoing, and I picked a few crops to really highlight, for example, when you're growing crops that need to be transplanted versus direct-seeded crops. So some of them are conducted at our station trials, and some of them are actually carried out on farm. So again, I also want to thank all the collaborators who I listed here on the slide. Really has been a very, very interesting and fun journey to actually explore ASD as a tool that could be used by, in this case, particularly organic vegetable and strawberry growers in terms of enhancing weed management as well as disease, pest management, nutrient management, and to improve the overall health of plants as well as productivity. Of course, we are also hoping to maximize the gains to look at long-term impacts of using ASD. Okay. So let's see, just for some of you who might not be very familiar in terms of our production environment and systems here, I just want to give a very, very quick introduction to the environment and soil conditions we are working with here. So again, in this talk, I'm going to focus on strawberry and broccoli and some work on salad greens as well as carrots. And you can tell from some of the pictures here. And I have this map to indicate that the trials we conducted primarily happened in Gainesville and Citra. You can see they're located in North Central Florida here. And in terms of the hardness zone, you can see actually for both locations, they are in the zone of 9A. So some of you probably very familiar with this organic survey conducted by USDA. I do want to put it out there. As you can see that the crops I'm focusing on today, they really represent some of the top selling organic commodities based on the market sales in the States. Okay, so what are the major challenges that we're facing here in Florida in terms of organic vegetable and strawberry production? So many of the vegetable crops are grown in sandy soils here with relatively low organic matter content. I would love to hear more information later during Q&A in terms of the soil organic matter levels people are working with. But here in Florida, in many of our research trials, especially conducted in Central Florida at one of our research farms, we are really dealing with organic matter level below 1%. So very low organic matter in terms of poor capacities of retaining water and nutrients. As you can see that nutrient leaching can be a very, very major problem here. That is why really among disease, pest, and weed management, we are dealing with soil nutrient management as well. And BMP is really a big, I would say a big theme here that we really, really need to address. And long-term soil health is really another, I would say, sustainability task that we also need to tackle. So the question here is that as we are examining multiple approaches and integrative tools, we would like to look into ASD to see how ASD can actually fit into the organic production systems here in Florida sandy soils to really help with, for example, weed management, and may be able to provide other benefits as well, and also looking at long-term benefits that ASD can bring to us in terms of enhancing the overall sustainability of organic cropping systems. So I'm going to start with the strawberry case study first, since we have done really a lot of work in the past 8 to 10 years focused on organic strawberry production systems, really looking at multiple factors and holistic approaches in terms of integrating different tools to help improve organic strawberry production here in Florida. So in terms of ASD application in strawberry here, in this particular study. It's a two-year experiment in the field, and we're looking at application rates of molasses and abilizer. As Francesco mentioned, molasses has been used as one of the major sources for labile carbon here for ASD setup in Florida, particularly because it's relatively, I would say it's locally available because it's a byproduct in the sugarcane industry here in Florida. So the abilizer, we also consider that as a nitrogen source. So during the anaerobic decomposition process, during the ASD treatment, you want to make sure that you also provide nitrogen there to facilitate the ASD process. And also the abilizer product, which is also another one locally available, heat processed chicken manure. It also brings organic matter to the soil to help actually hold water, and again, also playing certain roles in terms of facilitating ASD setup there in the field. So in this particular case, we had 25 combinations consisting of 5 molasses rates and 5 abilizer rates. So, okay, again, as you can tell, our sandy soil condition here, about 93% is sand in terms of soil texture. And in this particular study, the site had an organic matter below 1%. So in terms of the strawberry management, again, I'll have photos later to follow. It's a 3-week ASD period. And in this particular study, we focused on one strawberry cultivar, and then we also implemented in-season fertigation across all treatments here. Again, there are 25 combinations of different rates of molasses and abilizer application. So again, here shows you the whole process in terms of our 2-year studies. Also, we try to make sure we follow growers' practices as well. So here in Florida, during the summertime, before fall planting of strawberries, many growers, especially organic growers, of course, including conventional growers as well, to actually grow a summer cover crop. In this case, sun hemp really has been commonly used by many strawberry growers and even other vegetable growers during the summer off season to, again, bring a lot of agroecological benefits in terms of growing cover crops. So all the treatment plots actually received cover crop during the summertime. And then in around mid-September, we come in to set up the 3-week pre-plant ASD treatments. Again, 25 combinations in terms of different molasses and abilizer organic fertilizer rates here. So 3 weeks later, and we are going to punch holes and transplant bare root strawberry plants in this particular case. Again, bare root plants are also the major type of strawberry transplants used by many growers here in Florida, and then turn on the overhead irrigation for about a week to help strawberry establishment due to the hot weather conditions at that time. And as you can see, the picture here showing the establishment of the Florida breedings, which is a cultivar used in this particular trial in the middle of the season. Okay, so I'm going to really focus on weed management here. We have collected a lot of data because we have multiple objectives in our ASD studies, but in this case, for this seminar or for this webinar, I'm going to focus on some of the interesting findings that we saw in terms of weed management or weed assessment. So here, if you could recall, Francesco also showed a figure indicating the redox potential. Here, this particular slide shows the cumulative values in terms of different treatments. You can probably tell that in general, our values might be lower than what Francesco indicated. So I want you to think about the soil condition differences between Florida and Pennsylvania in terms of the ASD impact on anaerobic conditions as well as other other impacts. So in terms of the 2 seasons, we're actually seeing something very consistent here in terms of the responses of the application rates of molasses and Avalizer to ASD treatments in terms of cumulative redox potential. So basically, the takeaway here is that they really tend to increase as the application rates of both input materials increases. So looking at the weed assessment at the end of the ASD period, again, for my talk today, and I'll be focusing more on the ASD impact on the weed management at the end of ASD period. So rather than during the cash crop production season. So again, you can see in this particular study in year 1, we're also seeing very interesting results here in terms of the impact of the application rates of molasses and Avalizer on the nut sedges per se at the end of ASD treatment period. So you can see that there's a particular trend as we are increasing, for example, the molasses and Avalizer application rate, you are actually going to see a reduction in terms of population of nut sedges in the beds at the end of the 3-week ASD treatment period. So that's quite promising in year 1. We were actually getting excited to see the results. However, in year 2, when we actually moved to a different location at the same site at our research farm, and we noticed really a very high pressure of nut sedges actually at the on-site of the experiment. So we also noticed the variability across the entire field where we set up our ASD trial. So we were really not seeing a clear-cut trend there in terms of how the nut sedge population at end of ASD period responded to the ASD treatments. So again, you can actually see the inconsistent results here. I do want to mention that the sun hemp that we grow in the summertime, their biomass accumulation also differed between the 2 seasons. So the first season, we actually get a greater level of sun hemp biomass, and the second season, the biomass actually decreased. And also we noticed the carbon to nitrogen ratio difference in the sun hemp biomass as well at the incorporation before ASD setup. So I'll have some information later on to also show you the seasonal environmental condition differences as well between the 2 seasons. So again, hoping that you think about how ASD is going to impact the cropping season, also interacting with the environmental conditions as well. So some of you may wonder, how about your strawberry yield? So since we have finished this 2-year study, I do want to share that, yes, from this heat map, you can actually see that relatively consistent in terms of, the overall trend regarding the application rates of molasses and Avalizer in terms of ASD treatments on yield performance. So because of this particular study, we actually identified, you can actually see the zone here. Yeah, so they're not too far from each other, again, giving the variability of the seasonal conditions between those 2 seasons. So we actually continued on in terms of selecting 2 most promising treatments with varying molasses and Avalizer application rates, comparing those to a control treatment without ASD, without molasses and setup. So this is the environmental condition here between the 2 seasons. As you can see, even if you look at the ASD setup period, you can actually see the differences there in terms of the temperature and also rainfall conditions, right? And also, I put the rainfall and air temperature conditions throughout the whole season for strawberries. You could actually see that the second season is quite rainy compared to the first one. So again, and also the temperature differences as well. So again, this is really a practical challenge. I want to remind all of us in terms of looking at specific tools to help us address specific production challenges, because you will have to deal with the seasonal variability here in terms of environmental conditions. So I mentioned that right now we're doing our year 3 study to look at those 2 promising rates compared to the control here. So we actually also looked at the the 6 cultivars. So we want to make sure that we, because in the first 2 studies, we only focused on 1 cultivar. So in this follow-up study, we want to see if there are any interactions between strawberry genotypes and ASD treatments in terms of the strawberry performance during the season. So speaking of the ASD impact on weed suppression during the treatment period, again, we were not seeing consistent trend here. And but visually, you might be able to actually see some suppressive effect due to some of the one of the 2 ASD treatments. However, it tend to vary again because of variability really at a higher level in the field in terms of nut sedges. Unfortunately, in Central Florida, this particular research farm, overall nut sedge population is pretty high at the research site. So, but something I do want to share for this particular case study, we're still in the middle of the season in terms of completing our strawberry trial ongoing. This is just since late November to late February, the strawberry total yield here. I do want to show that it's interesting that you can see, you can actually see that strawberry cultivars responded to our 2 selected ASD treatments here compared to control, but there's also variation. Seems like there are also some interesting interactions between the strawberry genotype and ASD treatments in terms of the yield performance of strawberry during the season. So again, this trial is still ongoing. I'll have more to share later. So moving on to quickly, a couple of other case studies I want to share. One is on broccoli. Again, in this particular case, it's transplanted rather than direct seeded. So this is actually a very interesting study that is right now still being conducted in Gainesville on campus, supported by Field and Fork Farm. So it's interesting to for me, actually to check on the plots on campus, because mostly we have to go off campus to do a lot of our research trials. So, so in this particular case, we have a lot of factors, but the overall goal is to look at how cover crop might be used as a potential carbon source, because you can actually, grow them on site and then utilize them more conveniently rather than actually transporting them from elsewhere. So we are basically, long story short, to compare the cover crop based ASD treatments versus the molasses based treatments here, and in comparison with a non-irrigated, no ASD control. Another interesting theme we want to bring here is a double cropping system. So basically, we grew all the warm season cover crops. In this case, we focused on sun hemp and sorghum stem grass, as well as mustard, again, individually. And we're putting them in a double cropping system. So again, after we terminate the cover crops, we'll set up ASD treatments, and then followed by fall planting of broccoli. Again, this is this trial is organically managed. In early spring, we'll come back and then put actually a special melon in the same bed to see if we are going to see a long-lasting impact of ASD treatments on the melon crop as a second one. So in terms of weed assessment, I want to share something very quickly here without showing you any data, because you can actually see we have very interesting, relatively consistent trend in terms of ASD suppressiveness on nut sedge. In this particular case, mostly yellow nut sedge at the end of ASD period. So again, compared to the no ASD control, our molasses and cover crop-based ASD treatments all perform really well in terms of suppressing nut sedges during the first season. In the second season, molasses-based ASD treatment also stood out in terms of suppressing nut sedges, but we're not really seeing significant differences between no ASD and the cover crop based ASD treatments, although numerically the cover crop ASD based treatments did actually have a lower population of nut sedges. And we're in both seasons, we were not seeing significant differences between those 2 ASD treatments. The last 2 studies I want to go over very briefly are focused on direct seeded crops. One is focused on salad green in both high tunnel and open field conditions. The other one is focused on carrots. So here, I think Francesco touched on that in terms of the film that you have to use or the covering material that you have to use for setting up ASD. So you can use really different type of mulching materials, including TIF, the plastic mulch, as well as silage tarp. In this case, we actually learned from a local grower here. They actually readily use the 6-meal silage tarp to help with management for a lot of direct seeded crops. So again, we're testing and also comparing the TIF versus the silage tarp based ASD setup here to see if we could actually use the silage tarp, because growers tend to use that for multiple seasons, and it's very challenging to actually use the plastic film for multiple seasons in the mulch beds. So again, in this particular case, we are comparing silage tarp versus TIF plastic mulch-based ASD treatments. So you can actually see that in terms of the anaerobic condition development differences there. Francesca also mentioned the temperature inference. So you can actually see summer versus the fall differences, and also impacted how those ASD treatments actually perform, as well as how the production systems, in this case protected versus open field, perform. So again, it is actually becoming more complex. So to really note the interactions between the ASD performance and the environmental conditions. Well, in this case, I do want to say that we saw very interesting effect due to the ASD treatment using silage tarp to suppress nut sedges compared to all other treatments. And overall, both ASD treatments help really suppress weeds and resulting in a very low weed coverage, not only during the ASD, but also throughout the production season. The last one I want to touch on very, very briefly is the carrot study. So this is an on-farm trial funded by SARE on-farm grant. So in this particular case, we are actually comparing ASD treatments to the grower's practice. So again, they have grown carrots for multiple years, so they have their routine practice in terms of weed management by using silage tarp. And we're also using silage tarp in this particular case, but introducing the concept or the tool of ASD to help suppress weeds and hoping to improve carrot production here. And also they have on-farm compost. So we're also integrating that compost into this ASD treatment. So long story short, in this particular study, because we actually had multiple trials in this project, we're definitely seeing some very interesting effects in terms of on top of the application of silage tarp ASD may actually bring some additional benefits in terms of weed management and others to improve organic carrot production. So what did we learn so far? I hope I already implied in terms of the take-home messages, because again, when you're looking at different crops, different production systems, and different seasons and different factors, it is very, very challenging to tackle, and in terms of the consistent impact of ASD. But we're definitely seeing some promising impact. And again, here I only focus on weed management. I didn't really touch on anything else. So some of the takeaways I do want to share is that, again, very important to find locally available and cost-effective carbon sources. So thanks to Francesco also touched on that, and to be really reliable from season to season, because that's actually one of the challenges in terms of using cover crops, the biomass accumulation and also the carbon nitrogen ratio and many compositional factors impacting the cover crop biomass. So, and again, viewing ASD as an integrative tool, how you can actually fit ASD into your production system to actually help you maximize ASD gains and minimizing maybe some of the adverse impact of ASD. And then we're also continuing our economic analysis to see whether it makes economic sense to really introduce or integrating ASD in organic system, and certainly more studies are needed. Hopefully we will gain a deeper understanding in terms of underlying mechanisms and contributing factors. So with that, I want to thank everyone who has participated in this in all the studies that we have done so far on ASD. Really, without their help, we cannot really finish or complete our trial successfully. And many others probably, many others also helped us. And thank you.
Thank you, Dr. Zhao. Mercy, you want to go ahead next?
Yep, absolutely. I just want to say that it was nice to see Francesco and Xin. I almost wore the scarf you got me, Xin, today, but I forgot. All right, so next up, we're going to switch topics, or at least switch from weeds to disease control. And Dr. Jenny Broome is going to talk about her experience researching diseases using ASD as a control method or as a tool. And I will say that Jenny is an assistant adjunct professor at UC Santa Cruz, researching grapes and berry health, plant health. She recently retired from Driscoll's after about 13 years as senior research manager, where she focused on plant pathogen diagnostics, management recommendations, and clean planting stock programs. Jenny has extensive experience in soil and plant health treatments, biological and chemical pathogen control, and global nursery clean stock programs. And so she's going to talk today about her experience and her research looking at ASD for pathogen and weed control in California berry systems. Go ahead, Jenny.
Great. Thank you, Mercy. Can you see my screen?
Yes, it's all great.
Okay, good, perfect. Okay, well, I feel privileged to be here today and be able to share the last 13 years, or actually even more, because I have one early project from when I was at UC Sarup years ago. But I'm excited to kind of cover work in the Central Valley, work on the Central Coast with organic berries, and even touch a little bit on plant propagation and nursery production systems and the use of this tool. And you can see, but I will focus more on diseases because I'm afraid I am a pathologist, but I'll touch a little bit on weeds. And obviously that's one of the most exciting things about ASD and biosolarization is the multitude of effects that you get. And so on the left here, you can see a very devastated organic strawberry field by verticillium wilt. And on the right, an amazing amount of nut sedge. So I'm nicely building on several of the topics that both Francesco and Xin mentioned. And I look forward to sharing that work with you. So California strawberries are, and I'm again speaking from UC Santa Cruz here, and just over the hill from Aparna, and so many people in California will know this, but others may not. And so strawberries are grown on the coast, sometimes called the Central Coast, but it's sort of the central into the south. And California grows about 90% of US strawberries. 42,000 acres, of which about 12% are organic. It's about the 7th most valuable fruit and nut crop in California, $2.7 billion value. And if you look to the right on this other map, you can also see while much of the volume is on the coast, there are smallholder producers in the Central Valley, and then there are the nurseries that are called the low elevation and then high elevation nurseries in California for strawberries. I'm going to also touch on, based on the learnings we had from strawberries, we did some work in raspberries, and I actually think that at least in my experience working with Driscoll's growers, there's a lot of embrace of the pre-plant ASD in organic raspberries still to this day. For raspberries, California accounts for about 76% of US production. It's about 7,000 acres, of which a little over 2,200 are organic, so for about 30% of the acreage. And raspberries, a little lower value, but still up there, 29th in valuable fruit for the state. So I'm going to talk about some older work that was done in the Central Valley with small-scale immigrant farmers, Mien and Hmong farmers, and biosolarization work back in those days, and then also a little bit about strawberry nursery work, which again occurs in the Central Valley of California. And then I'm going to talk a bit about Central Coast work with organic strawberry, and finally some work with organic raspberry, and look forward to sharing. And also we'll go back and forth between bed-based treatments versus broadcast treatments for the berries, which is an important distinction, and has different costs and different benefits. And I do want to call out that I'm now pleased to be here at UC Santa Cruz and a colleague directly with Joji Muramoto and Carol Shannon, but a lot of this early work in the ASD was with Joji and Carol, and really felt privileged to work with them. Also worked with Aaron in Florida with some of the work that was just presented as well. So as Francisco mentioned, you need to think of ASD as part of an integrated system, whether it's for pathogens and or weeds. And there are many other practices that should need to be obviously put to use. And in general, when you have a problem with pathogens or weeds, that's what we're going to talk about today. But there are various other tools in the toolbox that I just want to remind you that ASD alone is not a panacea. It's not the sole solution. So ASD was developed, Francisco did a great job of giving the history of that, Netherlands and Japan, and as an alternative to fumigation, there had been earlier work with biosolarization in Israel, Spain, and the US from the early to late 80s into 2000. And one of the differences is really with biosolarization, I think of as ASD with clear plastic, a longer treatment period, and not always such a easily decomposable carbon source and warmer climates. But the same steps are used in both. You incorporate a carbon source, and nitrogen, as was mentioned. You moisten the soil, you cover with plastic mulch to reduce or eliminate oxygen and maintain the decomposition. On the top there, that's some ASD going on in a nursery in the Netherlands, and on the bottom is work I'll cover next in biosolarization in the Central Valley. I'm going to skip this slide because I feel like the previous two speakers have gone over it really well as to the issues that need to be taken into account in order to successfully do ASD. It's not always easy, and we definitely had some challenges and quite a few successes. Soil type greatly influences the success of an ASD treatment. We mostly worked with rice bran, also a bit with wheat bran, a little bit with cover crops, and a little bit with food waste. So we mostly focused on solid ag byproducts. I was intrigued to hear the previous researchers' experience with the liquid, with the molasses. When Joji and I did work with it here in California, we couldn't get it to work as well. So I do think there are variations I believe that was probably related to the differences in the soil types. So I think we're really privileged today with this session. We have Pennsylvania, we have Florida, and we have California, and they're quite different. And again, California is a Mediterranean climate and has influences on all of this. So the work in the Central Valley and Sacramento was with Stephen Lee and also with Chuck Ingalls, who I'm afraid is no longer with us, but was a fabulous farm advisor that I worked with for a couple of years before coming to Driscoll's. Those growers, again, you want to know what your growers' challenges are and try to be creative in addressing them. And they were experiencing dieback, they're heavy clay soils, and there was potassium deficiency that we were seeing. And some of the symptoms are shown there on the bottom left. So we dreamed up a treatment of addressing the deficiency using compost and also adding potassium sulfate and doing a biosolarization with clear polyethylene plastic with some additives for inhibiting breakdown of the plastic. And then we looked at Chandler and Seascape. And we removed the plastic and put black plastic down, which can be a hassle. But you can also do a white latex painting of the plastic, which was Small Farm Center folks did a lot of work in that 20 years ago. So this is a description of the wine grape pumice and poultry manure compost, and it little bit of salts there, but not too bad, and a lot of nitrogen and a carbon to nitrogen ratio of 24:1. And we set it up well. It was just in the middle of the summer. We got really good conditions, 120 degrees Fahrenheit for a good number of days was the maximum temperature, and then the number of days with at least 1 hour over 95 compared to the bare ground. And in terms of weed control, we got 100% weed control with the solarization, either with the amendments or without. So a biosolarization versus a solarization. And then quite a bit of weeds, as you can see there in the bottom picture. And yields, definitely the best was the combination with the biosolarization. And then kind of went down from there, but not terribly significant differences, but meaningful for the growers, and especially with the weed control was very, very valuable. Later, a couple of years later, again, still in the Central Valley, did some work with Lynn Epstein at UC Davis, and we did a really nice ASD trial, flat broadcast with rice bran. Again, we love rice bran in California. Unfortunately, the price has gone up, but it is incredibly convenient to work with, and but you're competing with its use as animal feed and other issues. Other uses, and so the price is now almost $400, I think, dollars a ton. So it's expensive. And we worked with TriCal as a fumigant company. They are interested to offer alternatives and lay the drip line down I think this was every foot, but sometimes we've done it 18 inches. And do the processes as explained by the previous two speakers. We also, with Melody and had a variety of treatments here, steam as well as ASD, but it actually over yielded in terms of plant yield. So this is in a nursery setting doing ASD with rice bran. Very successful, again, with the very warm temperatures in the Central Valley. We were quite impressed with the results that we obtained. To go now to the Central Coast, where I'm located, where Aparna is, where Mercy is. Over the years, quite a few years, starting in about 2011 until about 2023, we did a variety of trials with Joji. And again, applying the rice bran broadcast, incorporating it with really nice large scale rototillers that the growers had, listing the beds, applying the drip tape and mulch, and then irrigating about adding 1 to 2 acre inches over a 3-week period, and then doing appropriate monitoring to know that you've gotten the conditions. And we on average got 10 to 15,000 pounds per acre increase in our yields, which was substantial, and control of verticillium when we did this in what I'm calling a broadcast application and bed fermentation, September-October timing. We also did some work along with Joji and others on a broadcast application followed by a broadcast fermentation. Again, similarly, applying the rice bran, incorporating it very well. That's really important to get very good incorporation, well distributed. And then working with a company like TriCal to apply the drip tape under the plastic. And it was always PIF, which was more efficacious. And then you let it go for about 21 days with the water. and monitoring, and pull that up and then make up your beds. We got Joji and colleagues did 2 seasons of work and showed control of fusarium if you did it in the summertime with this broadcast treatment. We did work with macrophromina and showed pretty good control in the summertime broadcast treatment against macrophromina and strawberries. If we move to raspberries, again, we started moving from our learnings from strawberries into raspberries at the time. Driscoll's produced maybe almost 90% of the US raspberries. That's been reduced a bit, but it's a very important crop. And we looked at both rice bran and we looked at mustard seed meal and did a trial. High rate again, 9 tons per acre, but a lower rate of mustard seed meal. Many growers were using mustard seed meal, but not using it like we were with tarping and doing an actual treatment. And that I think is important to keep in mind. That's key. At this location, we didn't end up having much in the way of any diseases, but we were interested in looking at weed control because this grower had a lot of nut sedge. And indeed, we got some, if you look at the untreated control, mustard seed meal and ASD, at 3 months and 6 months after the treatment, we still had lasting effects on amount of nitrogen present, and pH reductions, which again, raspberries are very responsive to reduce lower pHs, and the normal pH of soils and water in this area is definitely tending toward more alkaline. And in terms of yield, we saw significant yield benefits in the cumulative yield with both the ASD and the mustard seed meal treatment. And we're excited about that. And then a lot of our growers started using that treatment, and they did a more automated system than what we did as researchers, applying it to the beds and then rototilling the bed, laying down the tape, and then the mulch, and have been successfully using this methodology. Especially in the northern district of California around Watsonville, most of the growers are all doing a pre-plant ASD treatment before their raspberry plantings. One of the reasons they can do it a little easier than some of our strawberry growers, some of the strawberry growers, is that the raspberry doesn't plant until, say, December, January. And so there's more time to do this treatment before they need to plant. Whereas strawberries, it's pretty quickly you come out of strawberries and you have to go back in again. Just wanted to show something fun, a little bit out of the US to Mexico. Back in 2012, we did some work with biosolarization based on my earlier experiences, and saw very beneficial effects. And the growers are still doing that. They can do it during the Semana Santa, during the dry season in April, May into June. They tend to use compost, so they're doing more, in theory, of a biosolarization than an ASD treatment. In terms of the compost has kind of gotten pretty less available carbon, more already decomposed, and but very successful control of improving shoot emergence from the roots, white grub control, and Phytophthora control. And so it was fun to see still fairly extensive use of that technique there. Final part of my talk, I think we're doing okay. There was one field that the grower was ready to give up on it, basically, so much disease and problems. And then we were noticing the high cost of rice bran, so I wanted to find some other carbon source. And so this trial, we compared what is our standard of 9 tons rice bran per acre to 6 tons rice bran and 3 tons of almond hulls, which there's a lot of almond hulls in California. And then the grower was routinely doing a bed-applied ASD, but was not getting the control that he needed. And like I said, was ready to abandon this field. And then an untreated. Unfortunately, it's sort of a big, not so replicated trial, demonstration trial. So the positioning of the untreated was not a deal, which I'll get to in a minute. But generally, we had a really successful treatment. Can see here, so we get the rice bran delivered, we got the almond hulls, and just reminding people it's mostly the hull with some of the shell thrown in. Here it is being applied, and here we are working with TriCal again to do the application. And indeed, we got about 7 weeks of anaerobic conditions for both of the broadcast successful ASD. But unfortunately, the grower didn't start his treatment until late October, and only went for 4 weeks, and he did not get any anaerobic conditions. So it was a failed treatment, which can be a problem. And that was another thing I wanted to share with folks, that we've seen blow-ups of certain diseases when you do this treatment and don't do it successfully. So it's really important to be on top of that. But for this trial, for the broadcast treatment, we had a very good control of nutsedge. The right side is no ASD, and the left side is the ASD, just completely cleaned up for the first year. So with raspberries, you have 2 harvests. You have a primocane season 2020 and a floricane 2021. And we saw some decent weed control in the first year after the treatment. Not so much by the second year. There was some reinfestation and less control. But we also saw control of Phytophthora, which was quite impactful in this field. And that was really exciting to see. And then my colleague, research colleague, Kelly Ivers, very carefully documented the amount of the pathogen that was reduced by the broadcast ASD treatment. But in the failed bed-based ASD treatment, the Phytophthora numbers went up. And so for whatever reason, in terms of maybe being a little more competitive, a saprophyte that can feed on the rice bran, that was unfortunate. So to summarize that trial, we reduced disease in both seasons. We reduced weed pressure, mostly in the first season, the primocane season, and yields total and marketable were increased, as you can see here, pretty substantially. And the grower was very happy with it. And many of then the rest of the growers in the Northern District started doing this practice. However, they are doing the bed-based practice, not the broadcast. And we only did the broadcast because there was so much disease in that field. But the cost, as you can see at the bottom there, is pretty substantial to do that treatment ahead of time. So you need to only be doing it if you have a bad field that needs cleaning up, basically. So to summarize, we have the bed-based biosolarization treatment in the Central Valley with the small-scale organic growers was quite effective, and a warmer, drier climate there with the clear plastic and the compost amendments. And there's a lot of organic, byproducts of food processing in the Central Valley that a lot of other researchers out of UC Davis, like Greg Brown and Chris Simmons, have been very effectively making use of those waste products, as has Oleg down south with wheat midds and with coffee grounds, etc. And then we also found it could be quite effective for strawberry nursery production, again, in the warmer Central Valley with the clear plastic. On the Central Coast, Joji did a lot of early work and found that you don't, for the bed-based production or ASD, you don't need the clear plastic. But if you're going to want to control something like Macrophromina or Fusarium, you are going to need a summertime warmer temperature, and clear plastic is my experience to really get repeatable control of the pathogens and consistent yield increases. And finally, Central Coast raspberries, ASD with rice bran and or with mustard seed meal and or with the adding some of the almond hulls has been highly successful for controlling for basic yield increase and increasing the number of canes that emerge from the roots. Raspberry growers use roots generally to do their planting stock, and they have a little more time to do that treatment pre-plant, which makes it easier to work in their production system for now. So I think that is it. I wanted to call out that the organic production manual is getting revised and should be out in 2025. Mark Bolda and Oleg will be moving that forward, and I have a chapter or two in there. And special thanks to many folks that helped me over the years with all of this work, or inspired me, or first taught me about biosolarization, et cetera. So looking forward to a dialogue and discussion after this.
Thank you so much, Jenny. Really appreciate it. It was a nice bridge between weeds and diseases and everything like that. So that's great. Awesome. Lucy.
Thanks, Mercy, and thanks, Jenny. Hi, all. My name is Lucy Diekman, and I'm another cooperative extension advisor working in the Central Coast. And it is my pleasure to introduce our final speaker for today, who will continue to talk about solarization and biosolarization for the control of pests. So please join me in welcoming Martin Guerena, who is a sustainable agriculture specialist and Western Regional Coordinator with the National Center for Appropriate Technology, where he provides information to farmers, ranchers, and agricultural educators on sustainable farming practices and pest control methods. Martin has many years of experience as a teacher, a farm manager, and an extension agent with the University of Arizona. And I think you are all set, Martin. Feel free to get started. Martin, I don't know. Oh, okay, it looks like you're maybe putting it into presentation mode. If you're speaking, we can't hear you.
Okay, you can hear me now.
We can hear you now. Okay, yes.
Okay, can you see my screen?
I can see your screen.
Okay, let me do the slideshow. Okay.
Looks perfect. Thanks.
Great. Well, I was saying, I just got in like 15 minutes ago from Woodland, and I was in the face-to-face organic weed control meeting that Margaret Lloyd had up there. So I saw some interesting things there, and then I rushed down Road 102, those of you who are familiar with the Davis area, and made it here in time. I don't know what was covered before. I caught the Jenny's presentation, but so I'm gonna kind of go through some stuff, and if you've already seen it or already been talked about, I'm sorry. I'm gonna skip over the anaerobic soil disinfestation, which I'm sure you guys heard plenty about. Anyhow, this is a result of a grant I got from Sustainable Ag Research and Education about 3 or 4 years ago. And what I did was did solarization and biosolarization trials throughout the Central Valley pretty much, and in the Cape Hay Valley. So I'm going to briefly go through some of this stuff. I am focusing mostly on weeds, but I will touch a little bit on pathogens from my experience. This gives you an idea of the number of seeds produced by these common weeds, and then the longevity in it. So it kind of gives you an idea of the seed bank, weed seed bank that you deal with. And, you know, it's astronomical figures. Imagine this is per plant. Imagine, you know, square foot to an acre to 10 acres, 100 acres, whatever you're dealing with. Lots of weeds. And then the tillage practices, bringing stuff up all the time. So you have a constant supply of seeds in the seed bank. So this is kind of a little graphic here depicting what goes on in the seed bank. Of course, not all the seeds survive. Some are preyed on, some have natural death, some don't germinate fully, but those that do, you know, they emerge pretty uniformly and establish themselves, and of course, continue their life cycles. So it's a continuous process. So solarization, of course, you probably were explaining this before, but basically pasteurizing the soil. I found that the key to its success is having moist soil and being able to seal the edges of the plastic to trap the heat and the gases that are produced. Besides, you know, killing nutrients and killing weeds and pathogens, it also helps with remediation with certain toxins, as well as releases a lot of nutrients to the plant. And whether it's chemical fumigation or, you know, solarized, you know, you get this kind of burst of energy, and the plants, you know, grow bigger and stronger. And there's various reasons for it. Of course, a lot of it with the dead microorganisms there that become, you know, that release and mineralize a lot of nutrients. Anyhow, so this is a, you know, garden explanation of how it works. You basically work the soil, you smooth it out. Like I said, moisture, I think, is your number one, and the ability of the soil to hold that moisture, and then sealing the edges of the plastic to be able to trap the heat during the process. So I've done it in two ways. I've done the bed fumigation, as you see here on the left, and then I did about an acre of reclamation. We were trying to establish a native grass garden, if you will, or open space. This is in a park in Davis. So I'm going to focus here on the flat fumigation. The advantage to the flat fumigation I found is that if you do it right the first time, you don't have to go back to, let's say, a bed fumigation to get the areas, you know, in between the rows that are not solarized. So with a bed fumigation, you probably have to go back and do it every season. With the flat fumigation, if you do it right, if you don't till and bring things up, you know, in the case that we did the restoration of native grasses, that was 10 years ago. And this was like the second year. You can see just there's like 3 or 4 species of California native grasses. Before that, it was full of, you know, wild oats, barley, a bunch of broadleaves, annual broadleaves, and now it's practically all native grasses. There was a broadleaf fillery that survived the temperature. It was covered for about 2 months, I think. And but we did a broadleaf selective application of herbicide to deal with the fillery, and that was the extent of it. 10 years later, unfortunately, I don't have a picture, but the stand is still there. The grass is big. And you do have fly-ins, things like prickly lettuce and other asteraceae, you know, that fly in. But the parks crew there has learned to keep on top of them and just keep the stand the way it is. So this was work done by Jesus Bayo Fernandez. He was at UC Davis for a while, originally from Spain. But you know, he did these beds with these thermometers at 2 inches and 8 inches, and kind of measured the fluctuation of the temperature at the time. So at, you know, 2 inches here, you had an average of about 35, 34 degree temperature every day. Down at 8 inches, you know, it was a little lower, but still warm enough, an average of maybe 32, 33 degrees throughout the experiment. What I did was I went the cheaper route and just got a good old cooking thermometer. Placed it, you can see here on the surface between the plastic and the soil. The ambient temperature was about 93 degrees, and you can see we're reaching almost 130 degrees right on the surface. And this is important because a lot of the seeds, you know, are up on the I would say, inch of the surface, and especially on the surface. So, they get exposed and, dispatched fairly well. At 3 inches, we were at 111 degrees, and at 6 inches, 100 degrees. Now, unfortunately, I didn't have I didn't measure a non-covered area, but the soil is a good insulator. So during that time, if you go down about 6 inches, you're going to have soil at about 60 at 70 degrees maximum, and that's what the seeds are used to. So when you have 100-degree temperatures up there, it kind of weakens them or outright kills them or prevents them from germinating. So that's a thermal effect of this process. The limitations, it takes a relatively long time. That flat fume that we did last about 2 months or 8 weeks, but you can do it as short as 4 weeks. Certain pests are heat tolerant in the case of the fillery. I'm sure Bermuda grass probably would die on the surface, but the rhizomes that are further down will probably survive and come back, as well as other perennials like field bindweed. It's dependent on local climate and weather. Here in the Central Valley, it works fairly well. Down in the desert, I'm sure it does. I've done it down in the desert. The only thing there is you get windstorms coming in, and a lot of times they'll pick up the plastic and, ruin the whole thing. So also limited control depth, depending on how moist you get the soil and how far down it goes. So biosolarization is basically the solarization process with organic matter. And of course, it equates to anaerobic soil disinfestation. But in the valley here, we use the clear plastic, and I used compost as the organic matter source. Other recommendations were, green waste, grounded up green waste, whatever, is available. Something that I've suggested, and nobody that grows vegetables would do it, but manure. Incorporating manure into the soil and having it go through these temperatures, will deactivate any, disease causing organism that people are, really afraid of. But there's so much manure, especially in the Central Valley and dairy, that, I would think this would be a good thing to do. At least start off growing, forages or something with it. But I think it'd be a good process. Or planting, for example, orchards with it. So I won't talk about this. I think you've heard quite enough of it. The thing was the time it took was about 2 to 3 weeks. With biosolarization, of course, we use transparent plastic. The process itself would go anywhere from 5 to 10 days. So compared to the solarization process, it cuts the time it takes to go through the process quite dramatically. Let's say you take a month to do it for solarization, and it'll take about a week with biosolarization. So the pest inactivation mechanism goes from having increased temperatures, of course, to oxygen depletion, being anaerobic, and then the production of volatile fatty acids, things like acetic acid or vinegar, butyric acid, valeric acid, and so forth. These are water soluble. So another thing you can do too is, once you do this process, is irrigate it well, and that'll push a lot of these fatty acids down further depth into the soil. Besides the fatty acids, depending what type of biomass you use, you can produce aldehydes, alcohols, ammonia, metal ions, volatile organic compounds that will deal with either your weed seeds or your disease propagules. The biomass application, at least the equivalent to 5 tons per acre. The finer the particle, the more effective it is. Incorporation into the soil to get better effects deeper in the profile. And like I mentioned, if you irrigate after, you can move a lot of the disinfectants down into the soil. I was also, I use compost, so there's a lot of organisms that are heat tolerant or can, tolerate the heat and survive it. The use of raw green waste, for example, is also recommended and, works with other microorganisms and, causes them to go anaerobic. And so advantages, of course, you have a shorter application time. You can recycle agricultural waste. It could be more effective in cooler, less sunny areas. It improves soil quality because you're adding organic matter. I mentioned the effect on deeper soil layers. And for example, if you use a cover crop as the organic matter source, you can incorporate it immediately and then continue and do the process. You don't have to wait for it to break down. This was average of the results I had for this Western SARE project. We had 8 farms, 2 in the interior coastal areas, one a creek, and the rest of them were around Cape Valley and Central Valley in general. So biosolarization was a little better, but no significant difference from solarization, but very much so a difference from the control as far as weed control went. Besides the weeds, here's some literature dealing with nematodes, both root knot and root lesion nematodes. And you can see biosolarization here was significantly as good as chloropicrin, slightly better than methylbromide. And for Pratylincus, similar results with effective control. For diseases, verticillium and rhizoctonia, this was done in Spain on artichokes, and they did use manure in this case. I think it was fresh sheep manure. And you compare the controls to various treatments, brassica and beer massage, and the fresh sheep manure. And they all got pretty good controls of both diseases. This was we had some leftover plastic that we put down, and actually it took this one, it was about 2 months, I'd say, near Davis, west of Davis, and ran the drip line for about 2 days, got it really soaked and just forgot about it. Came back 2 months later, pulled the plastic off, and you see the results. So we went in and planted garlic and onions. You can see the surrounding area that weren't solarized. So that's the type of weeds you would have found in that row. So very, very effective and worked really well, especially for hard to weed crops like onions and garlic and carrots also, I'm sure. Getting off of solarization, but still heat treatment. This was a steamer I saw on a field day in Salinas. Kind of like a locomotive, very expensive, over $1 million, but you can see right after it goes through, it has these shanks that go down about 6 inches into the soil. And even by touch, it's still pretty hot after it goes by. Then there's this smaller scale steamer, which is used at Fiery Ginger Farms here in Sacramento. And what it takes is this hose that has these little sprickets that release the steam. So you have this tarp weighed down by these chains. So we'll go in and steam this area for about 2 hours and then move it over to the next area you can see here. You can see what's left of the process, and then they continue for another 2 hours, and we'll move on and so forth along the line. You can see they planted onions here also. Very effective both for diseases and for weeds and diseases. These tunnels, when I started working with this farm, they would easily lose about a quarter of this lettuce to sclerotinia lettuce crop. After they started the steaming process, they practically harvest everything. They don't have any weed issues, and of course no disease either. So very effective. So a lot of people ask me, so what about the beneficial microbes in the soil? Even though a lot of them are killed, a lot of them either survive or are able to recolonize the root zone very quickly. So yeah, there's an area that's always called the Goldilocks zone. That's just right, and these organisms are mobile, so they're able to go back and actually, feed off of the organisms that died during the process. Weed seeds and some disease propagules are, not mobile. They're pretty much in the soil and will stay there. So that's why I mentioned the flat fuming, just having to do it once and not worrying about it until you start seeing signs again that you might have to go in and do it again. So conclusions, biosolarization is as effective as solarization, but in less time, 1 week instead of a month. For biosolarization and solarization to be effective, soil must have enough moisture. Edges of plastic needs to be sealed well to prevent the heat and the gases from dissipating. Plus you want to anchor it. And then weeds not controlled by this process must be dispatched by another method, either mechanical. It's all part of IPM. And with that, I think I'm done if there's any questions.